Pre-statistics. Graphing quadratic functions in standard form. Part 3. Lesson objective. Find the minimum or maximum value of a quantity. Lesson objective. Minimum and maximum. In this video we will learn how to find the maximum or minimum value of a quadratic function. We shall see that such points always will be the vertex. These problems have many applications. For example, a scientist, engineer, or economist will be interested in such points for obvious reasons such as maximizing power, height, or profit, or minimizing losses or costs. So our first step is to see, will a quadratic have a minimum or will it have a maximum? Property. For a quadratic function, f of x equals ax squared plus bx plus c, whose graph has a vertex h, k. If a is less than 0, a negative number, then the parabola opens downward and the maximum value of the function is k. If a is greater than 0, a positive number, then the parabola opens upward and the minimum value of the function is k. Let's look at the visual. Here in this case, a is a negative number. We have a maximum, and that maximum occurs at the vertex, and it has height k. This parabola is opening upward. It has a minimum, so that means a is a positive number, and that minimum value is k. And again, the point is the vertex. Let's do an example. A fireworks shell is launched into the air. The shell's height in feet, h equals f of t, at time t seconds is modeled well by the function f of t equals negative 16t squared plus 200t plus 1. When should the shell explode so that it goes off at the maximum height? What is the height? Solution? A equals negative 16, which is negative. Therefore, the parabola opens downward, so there is a maximum value. The t-coordinate for the vertex is negative 200 divided by 2 times negative 16, which is a positive 6.25. So this means that 6.25 seconds after the fireworks is shot, it will reach its maximum height. What is the height? That's the h-coordinate. So we take 6.25 and we substitute that back into our quadratic. 6.25 squared times negative 16 plus 200 times 6.25 plus 1 gives us a height of 626 feet. So the vertex is 6.25. That gives us the time, and the height is 626 feet. So this maximum height will happen at 6.25, and that's when it should explode. And it will explode at a height of 626 feet. A person plans to use 60 feet of fencing and the side of his house to enclose a rectangular garden. What dimensions of the rectangle would give the maximum area? What is that area? So from the picture, here's the side of the house. We have W, L, and W that will make the fence, and W plus L plus W will equal 60. We want to know what is the maximum area that we can have using this 60 feet of fencing. Solution? Number 1, we define each variable. Let W be the width in feet, and L be the length, and A be the area in square feet. Number 2, we will use a system of 2 equations to build a function. We need 2 equations because we have 2 variables, W and L. So the first equation is W plus L equals 60. That is the fencing using the 3 sides. So next, W plus W, these are like terms, we can combine them, and we get 2W plus L equals 60. That's our first equation. The next equation is the area formula. So we know area of a rectangle is the length times the width. So we have our 2 equations and we can solve the system. I'm going to solve this by substitution. I'm going to take the first equation and I'm going to solve for L. So that means I need to subtract 2w to both sides. So we have L equals negative 2w plus 60. I'm going to take this expression and substitute that into equation 2. Now this gives us an equation that only has one variable, w. Distribute the w. We have negative 2w squared plus 60w. So this is a quadratic. A is negative, so we will have a maximum value. To find this maximum value, we use our formula for the vertex. So we have negative 60 divided by 2 times negative 2, which gives us 15. To find the A coordinate of the vertex, we substitute 15 back into our quadratic. We have negative 2 times 15 squared plus 60 times 15, and this gives us an output of 450. This is the area. To find the length, we substitute 15 for W. So if you recall, L is negative 2W plus 60. So this will become negative 2 times 15 plus 60, which gives us 30. So the width is 15 feet, the length is 30 feet, and the area is 450 square feet. So this is the largest area that you can construct using the 60 feet of fencing. To check it, 15 plus 15 plus 30 gives us 60. And if we construct a rectangle, say length 50 and width of 5, so this would be 5, this is 5, that's 10 plus 50, this would be 60, but this only has an area of 250. If we increase the width to 10, that means this is 10 and this is 40, so this would be 10 plus 40, which is 50, plus another 10 is 60, perimeter of 60, but this area is only 400. So using a graphing calculator, I'm using these window settings. X is a negative 5, so I can see the y-axis. My x max I have to 40, so I can see the end of the parabola. I'm counting by 5s. The y-man, I'm using a negative 150, so I can see the x-axis, and I want it to go to 500 because the peak here is supposed to be at 450, and then I'm counting by 50s. And using the maximum feature, the calculator is verifying that it occurs at 15 with an area of 450. So it verifies. Let's do our last example. The equation for the cost of manufacturing lawnmowers is C of x equals 0.008 x squared minus 0.04 x plus 75, where x is the number of lawnmowers in thousands and c is the cost. What number of lawnmowers should be produced to minimize costs? Solution? We know that it's a minimum because c is positive, so using the vertex formula, we will have negative b divided by 2a, which gives us a negative 0.04 divided by 2 times 0.008, which gives us 0.04 divided by 0.016, which gives us 2.5. Taking 2.5 and substituting it back into the function gives us an output of 74.95. So when the number of lawnmowers is 2,500, that's 2.5 times 1,000. This will be the smallest number produced to minimize the cost. To verify this using the graphing calculator, we hit y equals, type in the quadratic. I use the table feature. Starting from negative 5, I'm looking at the y values, so I can set my window, and we see that it's around 75, 74. Hitting the window key, I set my x-min at negative 5, so I can see my y-axis. My x-max I put to 15. I'm counting by 1. My y-min was 70. My y-max is 80. Because for all the values between negative 5 and 10, the y values were between 70 and 80. Hit graph. We can see this is a very wide parabola, and that's because the value of c is close to 0. If I hit second and trace, which is calculate, I want to select number 3, minimum. it asks for a left bound. It looks like the minimum's somewhere in here, so you want to pick a point that's to the left of the minimum. Hit enter. You get this little triangle. It's asking for a right bound, so again you want to pick a point that's to the right of the minimum, and you'll see another triangle, and then it asks for a guess, and your guess needs to be in between these two little triangles. Using this calculator feature, the calculator saying the minimum is about 2.5 and the y value was 74.95, and this is what we did algebraically. Thanks for watching.